Hello everyone, I am Khatchig Derjian. I will be your math tutor during this period of time. So, you know that in mathematics LS and GS sections, you have many chapters. One of the most important concepts for both of the sections is functions. So functions is an idea that is very important in many domains of mathematics, engineering, economics, and many other disciplines. And the most important ideas of functions are introduced in grade 11, and we continue with functions, which is a very important concept in grade 12. So let's begin by a small review of the main ideas, main concepts of functions that you did or you didn't in grade 11. You know, last year was a bit hectic year. Some schools had some problems. So let's begin by review. 3 sessions we were going to review the main concepts, and all the ideas that you think you are familiar with, you can just skip. And if you want, you may practice those ideas as much as you want. So let's begin by our first sessions about functions, the domain, limits, and the definition of functions. So let's begin to define a function. So, you know, definitions in mathematics are very important. But what is a function? A function is simply a relation between x and y, but you have only one condition. The only condition is that each x has only one y. So let's begin to think. For example, the number of or the points that the basketball player will score is a function of the games. For example, LeBron James cannot score 2 different scores within the same game, but it is possible to have 2 different games where LeBron James has scored the same score exactly. So the idea of function is that each x is the number of the games. In the example of LeBron James, we have only one y, which is the points that LeBron James has scored, or the assists that another player, let's say from the Lebanese context, that Wael Araqji had. So this is the main idea. So here you see that we have 2 examples. What do you think? Let's think about this. Which one of those is a function? So here you see that for each x you have only one y. However, here you see that for one x you have 2 different y's. Because for one x you have 2 different y's, then this is not a function. So this is not a function. However, this example is a function because each x has only one y. So this is a function. Here some students ask me, but here you have a problem. Well, this is not a problem, but basically one y has 2 different x. But this is not a problem. Even if for 2 different days you have the same price, for 2 different games you have the same points, this is not an issue. The important thing is the other way around. If for one x you have one y, then this is a function. Let's continue with the second slide. Here I have a bunch of examples. Let's think which of those are functions and which are not. Here you see that for each x you have one y. Let me give you some examples. For this x you have only this y. For this x you have only this one. So this is a function. However, here for the circle, you see that for this x you have 2 y's. Because for this x you have 2 different y's, so this is not a function. Let's continue with this shape. Here you see that for example, for this x you have one y only. For this x you have only one y, and all the way. So this is again a function. And finally, here you see that you have a sinusoidal function, and this again clearly a function because for each x you have only one y. So this is a small review of what a function is. So there are many students who think that why we need this. Well, basically you don't. No one will ask you what is a function, but we will be dealing with functions for many videos. So it is very important to know what is a function, okay, and why we deal with functions and where we're going to use those. So let's go with more practical ideas. So one of the main concepts and one of the main questions that you will have in mathematics exams is to find the domain of definition. You will see later when you deal with exponential functions, logarithmic functions, that you have different sorts of domains. But for now, as the first review from grade 11, only you have two sorts of domain of definition, two sorts of conditions. If you have a denominator, your denominator should be different than 0. And if you have a radical, the interior of the radical should be positive. Now, if you have dealt with logarithms, exponentials, those functions, you know that you may have different sorts and other conditions. But here, the main two conditions that you should know for now is the denominator and the radicals. Let me give you examples. Let's say we have the function f of x is equal to 1 over x minus 3. So what is the domain of definition of this function? So you notice that you have a denominator. Because you have a denominator, as we have seen in this slide, the denominator should be different than 0. So simply, we're going to put x minus 3 is different than 0. If x minus 3 is different than 0, then x will be different than 3. So because x is different than 3, then the domain will be from minus infinity to plus infinity without the value 3. So the domain of definition of f will be minus infinity, 3, union, 3 plus infinity. So those who are familiar with this concept, it's perfect. Those who are not, so we're taking all the values from minus infinity to 3, and we're taking all the values from 3 to plus infinity. Let's say we have the second function. In the second function, we have 1 over x squared plus 2x minus 3. Again, without even thinking, you take x squared plus 2x minus 3, and we put it to be different than 0. Here you should remember another concept from grade 11. You have a second degree equation. If you have a second degree equation, whether you're going to do delta or you're going to do on your calculator. So here, by our calculator, we're going to find two roots. x1 will be 1, and x2 will be minus 3. So this is a plus b plus c is equal to 0. So here we have two roots. In this case, the denominator has two roots, so there are two values that should be excluded. So the domain of definition of f will be from minus infinity to minus 3, union. Here many students forget this part. You should begin from minus 3 to 1, because you will take all the values that you have from minus 3 to 1, and you will take from 1 to plus infinity. So if I will represent this on a number line. So minus 3 and 1 should be excluded. Those values we shouldn't take. So we will take all the values here from minus infinity to minus 3. Then all the values here. This is from minus 3 to 1. And all the values that are here. And this is from 1 to plus infinity. Let's continue. Now, this is the second sort of examples when you have radicals. So you should pay attention. Whenever you have radicals, the interior of the radical should be bigger than 0. So here, 2x minus 4 should be bigger than 0. You have to solve this. 2x is bigger than 4, and x is bigger than 2. So the domain of definition of this function f will be from 2 to plus infinite. Similarly, if you have the radical of 6 minus 2x, so the interior of the radical should be positive. So 6 minus 2x is positive. So minus 2x will be bigger than minus 6. And here you should pay attention, because we have here the minus, so the order should flip. So we're going to have x is less than 3. So here, because the x is less than 3, so our domain will be, because it is less than 3, so we should begin from minus infinity till 3. Let's continue with the last function. So let's choose the blue. So here, again, the interior is x squared plus 2x minus 3, and this should be positive. But guys, here you should pay attention. This is a second degree inequality. To be able to solve this inequality, we need the roots and we need the table. So we're going to put x squared plus 2x minus 3 is equal to 0. And to be able to find the roots, I will take, because again we have a plus b plus c is equal to 0. So x1 will be 1, and x2 will be again c over a, which is minus 3 over 1, which is minus 3. Now we're not done. Here there are some students who will forget this. Pay attention, this is an inequality. Whenever you have a second degree inequality, you need to do a table of sign. So let's remember, again from grade 11, how we do a table of sign. So I need the x, I need the x squared plus 2x minus 3. Here we should put the values minus infinity, first the smallest, which is the minus 3, then 1, and finally the plus infinity. Now, we know that here the coefficient of x squared is 1, right? Which is positive. So this is positive. So here it will be plus, here it will be minus, here it will be plus. So those who are not familiar with this concept, let's remember, whatever the coefficient of x squared is, I mean the sign. So you will have first that sign, then the opposite sign, and then again that sign. So here the coefficient of x squared was positive. This is why first we put plus, then we put minus, and then we put again plus. We're not done yet because we haven't written the domain. So the domain, I will go back to the question. It's positive. So the domain of definition in this case will be the positive parts. So it will be from minus infinity to minus 3. And it will be closed. Why it will be closed? Because I have the equal sign. Union from 1 to plus infinity. So again, if you have a denominator, the denominator should be different than 0. If you have a radical, the interior of the radical should be positive. If it is a first degree, no worries, but pay attention. If the coefficient of x is negative, you should flip the order. If it is of second degree, you should pay attention again, because for the second degree, you should do a table of sign, and accordingly you should write the domain of definition. So this is the first part of our session. This is a review of the domain of definition. Now, after grasping this idea, we need to move on to the limits of functions. So what is the idea of limits? Even though I believe that most of you have worked a lot with limits in grade 11, but let's refresh our minds. So limits is the idea that whenever you have a number that is excluded, for example, in our case, the number 2 here is excluded. Because it is excluded, so we are interested what's going on to this, so what's happening to this function when x is getting closer and closer to 2. So here you see that if x gets closer to 2 from the positive side, which will be denoted by 2 plus, here you see that the function is increasing. So the limit of this function at 2 plus will be plus infinity. Similarly, if we get closer to this from the negative side, which will be denoted by 2 minus, you see that it will go to minus infinity, which is not always the case. You may have the opposite. Similarly, you see that, so the first idea is for the excluded values. The second idea are for the infinites. So if you're getting with your x to the left side to minus infinity, you see that your value here will be get closer and closer to 1. Similarly, if you take your x and you will take it to plus infinity, so to this side, you see that the value will be closer and closer again to 1. So we are interested about the limit of f of x as x goes to plus infinity, which is here, and minus infinity, which is there, and we are interested for the excluded value. I know that this may be a bit fast, but this is something that most of the students of grade 11 know, so we are just reviewing. So the main sorts of limits that you will need, whenever I talk about a, I mean positive or negative, but never 0. So you will have a over 0 plus. So something over 0 plus will be plus infinity if a is positive. A over 0 minus is negative infinity, again, if a is positive. However, if a is negative, a over 0 plus is negative infinity, and a over 0 minus is positive infinity. And a over infinity, positive or negative, it is always 0. So the main idea here is that something which is not 0 over 0 plus is infinity, negative or positive, and something over infinity is 0. So let's continue with the next slide. You know that from grade 11 we have 4 indeterminate forms. So the indeterminate forms are infinity minus infinity. What does it mean to have indeterminate form? Indeterminate form is when the limit will change according to the problem. So the indeterminate form is not a definitive answer. It means that sometimes it is 2, sometimes it is infinity, sometimes it is negative infinity, sometimes it is 0. So it will change. It is not predictable from the beginning. So those forms are the following: infinity minus infinity. This is not 0, guys. You cannot cancel the infinities because maybe this infinity is bigger. Infinity over infinity is the second indeterminate form. 0 times infinity is the third indeterminate form. And 0 over 0 is the fourth indeterminate form. So when you have indeterminate forms, whenever you have two very big forces that react, if you want, physically speaking, here the positive infinity will take your number infinitely big, and the negative infinity will take your number infinitely small. So the interaction of both you cannot determine from the beginning. Similarly here, if you multiply by 0 point something, then the number is getting very, very small. So your number is getting smaller and smaller. So here it's infinitely small, here this is infinitely big. Similarly here, if you divide by 0, your number will be infinitely big. So infinitely big times infinitely small, again it will be indeterminate form. So just remember those 4 indeterminate forms, and let's see how you're gonna deal with those indeterminate forms. So let's begin by the first one. Whenever you have a polynomial function, you know that from grade 11 you will take the highest degree. So this is the limit of x squared as x goes to plus infinity. You know that you can factorize, but it's not needed. You may do it directly. And then you're going to replace. This will be plus infinity squared, which is plus infinity. Here, whenever you have a rational function, which are the cases for the 3 other functions, you will take the highest degrees for the numerator and the highest degree for the denominator. So we will have 2x squared over x squared. And first you simplify, guys. If you replace here, you will have infinity over infinity again. So first you simplify. So you will have the limit as x goes to infinity plus infinity of 2. And you know that the limit of a constant is the number itself. Here we will have the limit as x goes to infinity of x over x squared. We simplify first. This will be 1 over x, and 1 over infinity is 0. And here, again, we factor out. This will be the limit of x squared over x, which will be the limit of x, which is minus infinity. So those are the simple rational and polynomial functions. Now, if you have a rational function, but the limit is not infinity, so you are not allowed to factor out the highest degree. You are not allowed to take out the highest degree. Here, if you replace, you will see that this is 1 plus 2 minus 3, 0 over 0. So this is an IF. So to remove this indeterminate form, you need to factor out. Again, because it is a second degree and it's going to a number, you will take the roots of those equations. So the first root is 1, so you will have x minus 1 into the second root is minus 3, so you will have x plus 3 over here the first root is 1, so you will have x minus 1, and the second root is minus 5, so you will have x plus 5. And again, we are happy, those will cancel, and we're gonna have the limit of x plus 3 over x plus 5. And if you replace here your number 1, you will see that you will have 4 over 6, which is 2 over 3, which is not an indeterminate form, and we are happy. So here, if you replace in the second form, you see that this is not a polynomial function, it's not a rational function, it's an irrational function, and you have a minus sign. So this is the limit of x squared plus 3x minus 4 in a radical minus x. So here you have different methods. One of the methods is to multiply this by its conjugate. Why we are doing this? Because here you see that this is infinity plus infinity, which is positive infinity, minus infinity, which is an IF. So here this is a minus b, a plus b, which will be, you should never forget to write the limit. So we will have x squared plus 3x minus 4 minus x squared over the radical of, x squared plus 3x minus 4 plus x. Now, on the numerator, we're going to have the limit of x squared and x squared will cancel. 3x minus 4 as x goes to positive infinity over the radical of x squared plus 3x minus 4 plus x. Now you see that again you have infinity over infinity. So to remove this IF, what we have to do is to factor out the 3x here, and here to factor out the x squared. So you see that here we're going to have a form that should be factored out. Yani here the x squared, we should take it to the outside the radical, which will be, so we will have the limit as x goes to infinity. So here we had 3x into 1 minus 4 over 3x. And for the denominator, you see that if you're going to take this x squared to the outside, we're going to have x. In general, you should have the absolute value of x. So I will write it as the absolute value of x. But because it is positive, you can remove the absolute value, and we're going to have only x here because x is positive. Why x is positive? Because it goes to plus infinity. If it was minus infinity, you should put it minus x. So this is x squared. We took the x squared. Then we have the radical 1 plus 3 over x minus 4 over x squared, and we had a plus x. Now, here we have a common x, so we're going to have the limit as x goes to positive infinity, 3, 1 minus 4 over 3x, over 3x, let's factor out this x. 1 plus 3 over x minus 4 over x squared plus 1. So here we factored out this x. Now we can simplify those x's. So we will have the limit of 3 into 1 minus 4 over 3x over the radical of 1 plus 3 over x minus 4 over x squared plus 1. And now you replace. And if you replace, you're going to have, because you have 4 over infinity, then it is 0. 1 minus 0, it's 1. 3 times 1, it's 3. You have a 3 on your numerator. And on the denominator, you're going to have 3 over infinity, which is 0. 4 over infinity, which is 0. 1 plus 0 minus 0, it's 1. Radical 1, it's radical 1, which is 1. And 1 plus 1, it's 2. So a bit complicated function that we solved, and we found the determinate form. So here you have another example. So I want you to try this, which is very similar to this one. And if you have any question, please do not hesitate to contact me through the WATAD website. So here the main difference is that you have minus infinity, not plus infinity. So whenever you have something like this, and you should take it outside the radical, it shouldn't be x, but it should be minus x. Let's continue with the asymptotes. So whenever you have the limit of f of x as x goes to plus or minus infinity is equal to a, then the line of equation y is equal to a is a horizontal asymptote. And whenever you have the limit of f of x as x goes to a is plus or minus infinity, so it's the opposite, then you have the line of equation x equals to a is a vertical asymptote. So this is the vertical asymptote, this is the horizontal asymptote. So the vertical asymptote is the line where you can never reach. So your function cannot intersect this line, especially at infinity for the horizontal asymptotes, and never it can intersect the vertical asymptote. So here we have many examples. So maybe it is better to continue with the examples next time. So in the next session, we will review the asymptotes, and we will continue with the ideas of derivative, table of variations. So we're going to have 3 videos about whatever you had in grade 11, similar to those. So in the next video, we will have asymptotes, derivatives, and table of variations.